Welcome to our presentation today on robot safety essentials, navigating standards, and practical solutions. Let me introduce today's presenters. Etta is our senior application engineer with more than 25 years of dedicated service at Schmersal, USA. She holds a Bachelor of Engineering in Electrical Engineering and is a TUV certified functional safety engineer. Additionally, Dawn is a TUV Rhineland certified machinery CE expert. Her extensive experience and expertise have been instrumental in advancing internal education and safety training initiatives within the company. Also with us today is Devin Murray. Devin is our Technicum Services Manager for Schmersal's Engineering Services Group in North America. He has written many white papers related to safety standards and general machine guarding, conducted risk assessments and validations, and developed and reviewed the implementation of corporate safety standards. He holds a Bachelor of Science in Electrical Engineering and an MBA from Alfred University, and is also a TUV functional safety engineer for machinery. So Devin and Dawn, take it away.
Perfect. Thank you, Dave, and thank you all for joining us this afternoon for this webinar. Whether it's your first time joining Schmersal and Technicum on a webinar, or if you are one of the regulars, we do appreciate you, and we hope that you get as much information as you can from this webinar. We have quite a bit of information. As Dave mentioned, there'll be two of us presenting. So let's go ahead and just jump in and look at what we want to discuss today as far as the agenda. We're going to start off by looking at just 10,000 foot view, so robot trends and safety challenges. We'll spend time today talking about some of the recent changes from ISO 10 to 18, which of course is the robotic standard. We'll look at what those changes were going into this new standard that was just published. We will then talk about some of the safety requirements from the ISO 10 to 18 standards and how the Schmersal products and Technicum services relate to those new requirements. We'll then end the webinar looking at an update to the ANSI A3 robot standard. And as Dave mentioned, we should have some time at the end for some Q&A. If for any reason we don't have time to get to your specific question, we will definitely reach out to you with the response and answer. But I think we're gonna have some time. All right. First things first. Again, 10,000 foot view. Real quick slide about the industry robot trends. Right? Why are we going through a webinar like this? Why has there been a sweeping update and changes for the ISO 10 to 18 robot standard? So just two quick bullet points here for the trends, right? So we see that there has been an increase in robot orders. We see here 4.3%, which correlates to an increase in revenue of 7.5% compared to the first half of 2024. Okay, and if we drill down a little deeper into that trend, we see that they're collaborative robots, and I'm using air quotes for that term, collaborative robots, and I'll explain why in a minute. Those cobots accounted for a growing share of the market with a little over 3,000 units ordered, and that value of $114 million. And those numbers are provided to us by the A3 report, or the Association for Advancing Automation. And if we just look at that as far as the increase in robot orders, we look at that globally, honestly, right? And we see companies investing more in automation, whether it's for a competitive advantage, whether it's because of labor shortages, right? Or maybe there's improved processes due to advancements in robot technology. Whatever the case is, there's a global increase in robot trends. And if we look at the Global Strategic Business Report and the compound annual growth rate for industrial robots from 2024 to 2030, which is the graphic there on the right, we see again a significant increase, at least forecasted, right, of 11%, which is a value of 100, a little under $163 billion. So again, we see it, this vast increase in robots and collaborative, quotes, collaborative robots usage. Okay. Now with this increase of usage of industrial and cobots, we also, of course, must take into account the safety aspect of it. Right, I mentioned just a second ago the advancements in robot technology. Robots are faster, move higher payloads. Even when we look at the term collaborative robots and what we're trying to do with those in the industry and how we're trying to have these true collaborative applications and having these robots work side by side with personnel, there is huge safety implications that we have to consider. Okay. Um, just yesterday, my colleagues sent me a news article, right? Says Tesla faces lawsuit after factory worker was knocked out by a robot. Man, that was yesterday, and it was a new incident. So of course, there's under investigation, and we don't know what the actual root cause of that will be. But at the end of the day, the headline was what an industrial robot accident. Okay, so yes, there's increase in uses of robots and cobots, but again, we have to take into account the safety aspect of it, which we will highlight here today with looking at ISO 10218. I jokingly said I'm using air quotes. Of course, you can't see me when I use the term collaborative robots, and that's because that looks into some of the changes that has taken place with ISO 10218. Before I get into a high level comparison of the changes of the new standard that was just published, I want to take a quick second to look at the definitions of a robot and this collaborative term here. So from 10 to 18, we have the definition of an industrial robot, which is a machine essentially that is automatically controlled, reprogrammable, or that has reprogrammable multi-purpose manipulators, can be programmed in 3 or more axes, which can be either fixed in place or fixed on mobile platforms for use in automation applications in industrial environments. Okay, so if you take out your checklist for this definition and you're checking the boxes, yep, this automatically controlled, yes, I have a reprogrammable manipulator, yada yada, you have an industrial robot. Okay, and these standards apply to you. If we then look at, okay, you know what, let's look at the task associated with this robot, right? And if we say, okay, well, do we have a collaborative task? Do we have a collaborative application? Again, look at the definition. Collaborative task, a portion of the robot sequence where both the robot application and the operator are within the same safeguarded space. And then we say, okay, well, what is a collaborative application? Standard says that a collaborative application is an application that contains one or more collaborative tasks. Okay, so they go hand in hand. But essentially, is this robot working in the same safeguarded space at the same time with this operator? Do we have a collaborative task? Okay, or more than one or so collaborative applications? If you do, again, this standard applies to you. And we have to take into account the safety aspects of it and how do we apply ISO 10218 to your application. And how do we make this safe? So just real quick look at the definitions as we prepare to dive into the standard. First thing is, do you even have an industrial robot? Like sometimes that's the question. Okay, sometimes we see a pick and place robot, but does that fulfill the definition of an industrial robot as far as 10218 is concerned? Okay. Um, this standard of ISO 10218 is a type C standard, which means that it is for a specific type of machine. In this case, we are looking at the requirements specifically for robots. Okay, so 10218 is a type C standard for robots. There is a part one and a part two. So the part one of this standard looks at the general requirements for industrial robots, and I list here the scope as pulled out directly from the standard. And part one specifies requirements for the inherently safe design, risk reduction measures, and information for use of robots for an industrial environment. The standard also calls out what's considered the stakeholders, right? Who should read this standard essentially? Who should be aware of the standard? And they list robot manufacturers, application integrators, health and safety bodies, the regulators, uh, robot application users, so the employers and the employees, safe providers such as maintenance personnel. And we look at that list, and it's, you know what, everybody who uses this machine, who touches this machine, has some involvement of safety in it, right? From the manufacturer down to the maintenance personnel and the employees. So we have to take into account this standard, right? And again, we look at the inherent safe design of this industrial robot. Okay. Again, there's two parts. So we look at ISO 10 to 18, 10 to 18, part two, what looks at the integration of the robot, right? So again, the scope here specifies requirements for the integration of industrial robot applications and industrial robot cells. Who should be aware of part two? We look at the standard and it's the same list. Okay, the same people. If you are a manufacturer of robot cells, if you are integrating this robot into an application, if you are purchasing this robot, if you're using the robot, if you are servicing the robot, you will want to look into ISO 10-18-1 and -2. Now, depending on your role, certain parts of the standard may apply more, of course, than the others. But this standard applies to, as we see here, all the stakeholders involved with these industrial robots and these collaborative tasks and applications, as we saw in the definitions there. Okay, so this is 10-18. There's been a new or revised standard as of February of this year. So we went from ISO 10-18-1 that was last published in 2012, and we looked at what that standard covers, and it essentially covers basic hazards and protective measures for safeguarding robots, okay, or the design of robots for part one. They did talk about collaborative operations, but that was at a very high level. There was no mention about cybersecurity, and as you see with a lot of revised safety standards that are coming out now, they are referring back to cybersecurity, thinking about the industry 4.0 or Internet of Things, right? So now we have to take that into account for our safety systems. Um, this older standard addressed topics, and we have the list here for stop and function, safe rated control systems, collaborative applications. But there was a lot of changes. There was a lot of things that they did not cover, as we see now in this list from 2025, and some changes as well. So with the 2025 revision, we now see that there's this robot classification. There's a class one, class two. I'll describe that in the next slide, but that's called on one of the next slides. But it's called out in this new 2025 standard. When you look at a class one robot, they will also give you some test methodologies to make sure that you are within the specifications of a class one robot. They also, with this 2025 revision, do talk about cybersecurity requirements, and they expand the capabilities of collaborative applications. They updated their information for functional safety, because there was, since 2012, there was a revision to ISO 13849, which is the standard for functional safety of machinery. The 2025 revision also incorporates the technical standard of 15066, which was the standard that was specific to collaborative robots. Okay, so the 2012 version again spoke about collaborative operations at a high level. That's why there was the creation of ISO TS 15066, which went into more detail and also provided some test methodologies to make sure that your pressure and forces, for example, did not exceed certain thresholds when you had those true application or true collaborative applications, I should say. They also expanded the information for use, and they provide more details for the modes of operations, safety function, stopping function, dynamic limiting. So again, more detail than what they presented to us in 2012. Okay, and again, I'll come back to the class 1 and class 2 in just a second here. When we look at the -2 version of 10 to 18 back in 2012, they covered the integration, the layout, the risk assessment, safeguarding, commissioning, and maintenance. Again, we're trying to integrate this industrial robot into an application. With that, they included requirements for the safeguarding spaces, protective stops. Yes, they did mention collaborative aspects, but again, that was at a high level. It was conceptual, much again why the ISO TS 15066 standard came out in 2016 to help guide those collaborative robot application questions and challenges. What we see with the revision here in February of 2025, there's this shift from the idea of a robot system to a robot application. They now look at collaborative applications, right? This is now integrated into the standard. And what we see is that a lot of information from 15066 has been incorporated into the revised standard. Okay, again, they expanded the functional safety requirements with the updated ISO 13849 standard. With the integration of an initial robot, they of course looked into cybersecurity, so they provide some more requirements or provide requirements on that, whereas before there were no requirements of it. New sections on end effectors, vertical transfer components, expanded information for use. Another big one here, the terminology updated from collaborative robot, which is why I was using the air quotes that you couldn't see, but collaborative robot is no longer being used, and we're now looking at the term collaborative operation. And this was huge, one of the huge ones, right? Because when we looked at this idea of a collaborative robot, I found, and I think it was kind of widespread within the industry, that there was this huge misconception of utilizing a collaborative robot, where yes, it's inherently safe designed, right? So it's slower speeds and supposedly no pinch points. But the misconception was we can buy or we can purchase this collaborative robot and plop it in and have a true safe collaborative application, right? We can work side by side with this collaborative robot because it says inside the documentation it's a collaborative robot. And that was a huge misconception, because you still at the end of the day need to do a risk assessment, and you need to find out exactly how we're integrating this collaborative robot into this application. And because there was, I think, right, there was such huge confusion that they just stripped out the term collaborative robot. And now we're looking at collaborative operations, which we just saw the definition of. So if you have a robot that is working in this collaborative operation, then we have to look at certain safeguarding measures, right? So there's no inherently safe collaborative robot that we can just plop into an application. Okay, so huge changes from 2012 to 2025, and I mean you can see there was quite some years in between the standards. So as we can imagine, there should be some sweeping changes for the positive, of course, for safety with these robot standards. Really quick, I mentioned that we now look at these classification of robots, and ISO 10 to 18 so there's two classes, class 1 and class 2, and here's a table that we pulled directly from the standard just to give you an idea of what we're looking at. So the classes of the robots are categorized by the mass per manipulator, the maximum force per manipulator, and the maximum speed of that robot. And if we look at those values of a class 1 robot, right, the mass per manipulator is 10 and under, right, kilograms, and the force per manipulator is 50 newtons and under. The maximum speed is under 250 millimeters per second. Those are essentially, right, those specifications that were for the collaborative robot that's no longer being used. Okay, so now we look at these specifications and we say, you know what, if we are trying to have a collaborative operation, we want to see if we can use these class 1 robots. We no longer are saying, yeah, we have this collaborative application, let's use this collaborative robot and call it a day. No, it's let's look at this class 1 robot for this application, and then the standard will gives us some testing methodologies. So I don't know if you can really see what's on the screen, but they give us some test methodologies to actually test the pressure and forces of the robot to make sure that these forces and pressures do not exceed certain thresholds of the human body so that we can utilize these in a collaborative task. Okay, side by side by the operator. Okay. We can talk about this more later toward the end of the presentation. But again, some huge changes within the standard. A lot of the information that they are describing with the testing is taken from ISO TS 15066.
Thank you, Devin. Now we will get into the safety requirements in practice, both for products and for our Tec.nicum services. The Schmersal Group is one of the international market leaders in the field of machine safety. We've got over 80 years of technical knowledge and special industry expertise in many fields of application that include the food and beverage production, packaging technology, machine tool construction, lift technology, logistics, heavy industry, and the automotive sector, and especially in the field of robot safety. So we offer a wide variety of robot safety products, from cutting-edge electronic safety devices to simple position sensors and various control accessories. We'll now discuss an overview of a selection of products that satisfy the requirements of ISO 10218 robotic standard, as well as with our Tec.nicum group. Schmersal provides product and manufacturer neutral engineering services. We will feature some Tec.nicum solutions to help you comply with the requirements of ISO 10218 robotic standard.
Perfect, perfect. All right, so what I want to discuss and what you'll see moving forward here, right, is let's look at the standard, and then let's look at some solutions, right? So if you look at some of the requirements from the standard, and we look at ISO 10218-1, and we look at the emergency stop, right, and then we have the section here. There'll be a lot of information from the standard. I won't read, you know, every word here or every line, every bullet point. But we look at the emergency stop function. The standard says that the robot shall have an e-stop, right? And then it tells us that the e-stop must conform to ISO 13850, which, you know, red mushroom, yellow background, self-latching, manual reset. Okay, so it calls out another standard, a type B standard for the e-stop. It also then will tell us that, you know what, the minimum functional safety performance for this e-stop has to be performance level C or SIL level 1. And when we look at performance level, that's from another standard, ISO 13849 that I mentioned earlier for functional safety. They also call out that the e-stop shall only be reset by a deliberate manual action. Now we look at even that statement, that is also a requirement for an e-stop as called out by ISO 13850, but again, this standard is calling that out in section 5.4.2 for an e-stop.
Yes, so like Devin said, in addition to the requirements of 10218, both the NFPA 79 and ISO 13850 do detail the physical characteristics of a push button type emergency stop operator, that red mushroom operator with the yellow background, that it be self-latching, and that once that emergency stop has been actuated, it remains in that actuated state until that voluntary and deliberate action has been performed, like twisting and or pulling of the palm button for manual reset. And in addition, by resetting that e-stop alone does not resume operation. Instead, that second deliberate reset action is needed, such as the pressing of a manual reset button. Both the OSHA and standards such as IEC 60204-1 state that that emergency stop must be readily accessible to the operator. That means that every operator station or any area of the machine worked on in which is considered part of the normal operating procedure needs a means for emergency stop, and it should be unobstructed and easily accessible without having to reach over, under, or around to actuate the emergency stop operator. So I just highlight here two possible solutions. We have a full complement of emergency stop operators to meet various different environmental conditions. I offer two simple kits. One is the BDF 100 series. That is a slim 40mm housing, impact resistant thermoplastic housing. That e-stop operator can be available with or without a protective collar around the red button itself. It does have an integrated LED status indicator above the operator, and this one would pull to unlatch or pull to reset the e-stop operation itself. It's integrated, fully wired. It's an M12 8-pin connection, so it's very easily wired into the electrical panel. And then another complete kit is our e-stop 201. So where the BDF 100 will give you one open and two closed contacts, the e-stop 201 will give you two normally closed contacts. And it's a complete kit that includes the operator, the contact blocks, the thermoplastic enclosure that has the yellow top so that you satisfy the requirements for the red operator, and the yellow background. So just two examples of some products that we have to offer for an emergency stop in the robotic application.
And if we move further down to the standards, and just then look at another section, so 5.5.2, they call out an enabling device. And with the enabling device, they again call out specific requirements, and they call out a 3-position as per IEC 60204-1. In the industry, for an enabled device, there can be a 2-position or a 3-position. So a 2-position is, off, on, 3-position being off, on, off. Okay, and they go into definition of what that 3rd position means. That off position having to go into a stop, a complete robot stopping, requiring a reset. The idea behind that is for the enabled device, as called out here by the standard for that 3rd position, is if you were to be exposed to a hazard, one of two things can happen. You can either drop the enabled device, and if you drop it, you're no longer in that middle position, so it goes off, or you tense up and you compress that enabled device going into that 3rd position, that compress off position that's called out in 5542. So again, this idea of a 3-position, and each one of those positions being called out directly by ISO 10218-2.
And the product solution that we offer from Schmersal is our ZSD5 or ZSD6 enabling device. You may know that as a live man switch, dead man switch, or just a handheld enabling device, or even a grip switch. It goes by many different names depending upon who you're speaking with. But giving you that 3-stage operation that's used in robotic cells to provide the operator safety during setup, maintenance, or troubleshooting activities, giving you that off, that on, that off 3-stage grip switch operation. You'll put that enabling device in the center position, hold it in its position to perform setup, maintenance, teaching the robot. As soon as you release that button or press it all the way down, that system interrupts the control command, and the contacts do not close on resetting from going from position 3 back to position 1. So the ZSD5 is simply the grip switch. The ZSD6 enabling device gives you an additional push button that's integrated into the device head for jogging functions, and both offer you an ergonomic design.
Perfect. If we start to look into some of the applications within ISO 1020-18, 1020-2, excuse me, we look at what they call out in section 555 for a monitored standstill. When we look at applications and we say, okay, the robot, in this case, obviously the robot stops. Okay, we interrupt the light curtain maybe, or request to enter, and we have a robot stop. And we have a standstill situation. And if we are not interacting with this robot, or that we are feeding it apart, or whatnot, it's not enough to state that it's that standstill. Right? We have to monitor this standstill, because if we're not removing power from this robot, if it's only at a standstill, we need to make sure that if the robot were to move, that we then put it into a safe stop. Maybe either stop category 0 or 1 based off your risk assessment, as defined by IEC 60204-1. So it's, yes, we're stopping the robot, but if we're not removing power from this robot with our safety circuit or lockout tagout, but from our safety circuit, we're not removing power, we then have to monitor to make sure that this robot is not moving. And that's the idea behind a monitored standstill safety function.
And Schmersal has a few options to provide you with that standstill monitoring, that monitored standstill. Our PSC1, our programmable safety controller, that gives you that programmable compact controller with built-in I/O on the main module, with various different I/O extension modules that will ensure the safe signal processing of the e-stop buttons, the light curtains, the safety door interlock switches, and other electronic and mechanical safety switching devices. And it's possible to monitor safely multiple axes using numerous functions. So it's modular and freely programmable. We offer PSC1C10 with safe drive monitoring for 1 or 2 axes, the PSC1C100 with external safe drive monitoring modules, giving you the ability to monitor a maximum of 12 axes, giving you your safe shutdown with safe torque off, safe stopping with safe stop 1 or safe stop 2, safe operating stop, as well as safe movement, your safety limited speeds, your safe direction indication, safe monitoring with safe cam, safe positioning with safety limited positioning, safety limited increment, safe emergency limit. So that drive monitoring is carried out depending upon the application requirements with 1 or 2 encoder systems. And then a connection to all common field bus systems can be established with a universal communication interface to have that information brought back to any kind of existing communication field bus network. We also represent the company DINA out of Germany. So DINA provides safe drive monitors using a parallel connection to the 3 drive phases, allowing the frequency of the rotating field to be detected. So it's a standstill monitor that's measuring back EMF. And so that method for monitoring the drive can indicate specific motor speeds as well as standstill. It's cost effective because it doesn't require the use of sensors or encoders or any other measuring type devices. That technology can be utilized on 3 and single phase drives up to performance level E, rated up to 600 volts AC.
And I was going to say this is important, but they're all important. But I think that one is the monitor standstill is one that's overlooked a lot. 526 for actuating controls. Some of this, it kind of makes sense to us, right? It's like, well, of course, right? But 526 calls out the labeling for actuating controls, and that the label shall be clearly indicated to their functions. And of course, that makes sense, right? If we have a button, we want to know what that button does. But if we look at some maybe older robot systems that have been in use, and we look at the dependent station on there, the controls on there, maybe some of the labeling is rubbed off, right? But it's been used for some years, and everybody knows what that button does, right? So everybody, we don't need the label on it. Well, we do, and that's called out within the standard specifically. 5281 for the control stations also calls out the requirement for an e-stop on that on the control panel or on that actuating controls. And also that last note there for a visual signal at the control station shall indicate the active status of the control station. So again, yes, labeling makes sense, but something we have to remember for older equipment, and then also that e-stop one there.
And so again, Schmersal has a solution for that with an abundance of different control panels available. 3 different series, depending upon the size. Slim 40mm wide housings, impact resistant thermoplastic. The BDF 100 again is that single operator. You can have an e-stop and or the various different types of other control devices, as well as a multiple operators into the BDF 40, which is a slim housing, a slimmer footprint than the BDF 200. So again, up to 4 operators in one housing. You can incorporate the e-stop into that control panel, and or you can have another panel with 4 other operators that can range from illuminated push button selector switches, LED indicator lights, pilot lights, keyed operated selector switches, and standard push buttons, giving you the various machine or process controls conveniently located at each guard door. And then they can be configured and field labeled as required in the standards to user-defined application needs, including integrating that emergency stop operator as well.
The reset of functions 5522 from ISO 1015-1, and they also called out another unintended reset requirement in part 2. But for part 1 and 5522, the reset function, the reset function shall be provided to reset the interlock or reset the interlock, and allow the resetting of the internal robot safety functions. Right, this reset has to be a deliberate action. We look at this reset function. We want to look at the idea of that monitored manual reset, or that that 24 to 0 volt transition, to make sure that we are avoiding a failure with the reset button that would then turn it into an automatic reset, for example. We also want to make sure that we are preventing an unintended reset. All right, so part 2 goes into more detail, and we look at the integration of this robot cell, this robot into a robot cell or robot application, and it states here that an unintended reset shall be prevented by either accepting the release of the actuator from an energized on position, and that's that monitored manual or that 24 to 0 volt transition reset, or they give an example of an activation of 2 zones, like on a touchscreen, which is considered a double reset function, trying to prevent the unintended reset.
So in addition to the control devices that we offer just for your standard manual reset, we also offer solutions to convert any standard reset circuit into that double reset circuit. So you're enhancing the safety function of a standard safety controller or safety PLC. It prevents the reset of the machine or the equipment if the operator is inside the hazardous area who may not be seen. So when you do have an operator that you might lose line of sight, they begin that resetting procedure by first actuating a reset button inside the walk-in area after leaving that area, and having the presence sensing device like the light curtain cleared, or re-engaging a safety interlock that's on the guard door, and then actuating that second reset button outside within a predetermined time required to restart that operation. And that sequence and that time prevents the starting of that machine based on visual inspection alone near a reset button located away from the view of potential hazards.
And then there's your reset function also. This application of a double reset we'll see later on, because we can also use that in place of some other safety function, but we'll see that later on again. Still some information to go through, looking at the time, but I think we're doing good, right? So going back to ISO 1015-2, we look at guards, and they have 5.8.5 for guards. And they call it another standard for 14120. They say that the guards shall conform to ISO 14120. The fixing system shall remain attached to the guards, which means that the fasteners are captive to that guard. So if there's 10 fasteners on that guard and you unscrew 10 fasteners to remove that guard, those 10 fasteners remain captive, so that 10 fasteners come off, 10 fasteners go back on. The minimum distance associated with the openings, they call out ISO 13857, making sure that we can't reach the hazard by reaching through the openings of the guards.
So yeah, we've partnered with a company called Staytech out of Italy, and it's a modular fencing system perfectly suited for industrial robotic applications, made of low carbon steel for strength and durability and potential impact areas. The construction methods used of the assembled system are impact resistant up to 1600 joules in ISO 14120 dynamic resistance tests, exceeding the standards set by many automotive manufacturers. We will offer two particular series: our fast guard, which would be the fastest assembly, where the panels are slipping onto the footer assembly. There's no posts needed. Bolt connections on the footer, coupling clips for the tops, or the impact guard, which would be our maximum impact resistance. Bolt connections, threaded holes in the posts, extruded steel tube posts that are 40 or 60 millimeter profiles. All the modular designs meet all regulatory standards. They install quickly and easily. The fencing mesh itself is the 17 by 97 millimeter slot, so that narrow opening allows them to be mounted 120 millimeters from the danger zone, but also deters workers from climbing the fencing. There's no toe holds, and the panels are black, making visibility very easy into the robotic cell.
Perfect. Going from fixed guards, right? We look at the hierarchy control measures and seeing what we can do for rush reductions. Yes, if we can provide fixed guards around the cell, perfect. But of course, if it's a robot cell, we're going to require some access at some point to that robot cell. So the standard then calls out interlocks, right? And they call out within 5.2.4 that the interlock shall conform to ISO 14119, and this standard helps with the selection of interlocks. So there are different types of interlocks. They go into trying to help you understand how to mount certain interlocks and how to prevent bypassing of certain interlocks. So that's ISO 14119. And then the idea is once we have a guard that can move, then those guards have to be interlocked. Right, so we interlock these guards with these interlocks that are designed to ISO 14119. Okay, and then they go into some more requirements for a interlocked movable guards. So movable guards should only open laterally or away from the hazard. So some things we want to make sure that we consider when we are doing our design for the movable guards for these full body access areas. Or even areas where we are, open the guard to interact with this machine. Okay, so again, some things to keep in mind.
And the design, there's 5 different types of design of interlocking devices according to ISO 14119. You've got your type 1 uncoded mechanical operation, your type 2 coded mechanical operation, your type 3 uncoded mechanical operation, your type 4 coded electrical operation or electronic operation. And then of course, now they've newly added this year an update to 14119 is their type 5 key transfer or key exchange system. Selecting the type of device to be used is based on a wide range of factors, the desired safety level to achieve, the subjected environmental conditions, your cycling time for using the switch, and of course that possibility to manipulate the device and prevent that willful bypass. So that it allows for the design of that safety switch to range from a classic limit switch all the way up to a uniquely coded microprocessor-based device, depending upon your application criteria.
All right, and when we look at these guards, right, these interlocks for these movable guards, we're saying, or the standard is saying that you go to the guard door and you can open up the guard door at any time, right? And based off of the safety circuit, which we then have to look at to ISO 13849 for the safety functions, right? What performance level that safety circuit is designed to. But as soon as you open up that door, that safety circuit's gonna trigger that safe stop. ISO 10218 also looks at the situation if you have a guard that requires locking. So we look at interlocked mover guards with guard locking. This is section 5854. And they call out specifically that the locking shall conform with the following. Okay, so the permit the actuation of a hazardous machine function only when the guard door is closed and locked. So looking for those two functions, the guard door has to be closed and locked before you receive a safe signal to allow the robot to run, right? Before we can reset that safety function. And we have to keep the guard door in a closed and locked position until the risk or harm due to hazardous function has stopped. Okay, so we have to keep the guard door closed and locked. Then, if we look at the situation where we have full body access, if we have this idea of a locking guard door, Section 545 goes into detail to prevent someone from being trapped inside of the hazardous area. Again, this is something that I see overlooked more than it probably should be, right? If you have full body access and we can lock the door, we need to make sure someone can escape from this hazardous area. And that does not matter the condition of the lock switch. So if that locking switch is in the locked state, we must be able to unlock it from the inside and escape this hazardous area. That is the requirements from ISO 10218 for lock and guard doors in full body access areas.
And that guard locking function is safely monitored. So that's your solenoid interlock monitoring. And Schmersal offers an abundance of solutions working under different operating principles. You have your electromechanical, as well as an electronic RFID-based and a bistable operation with integrated emergency exit options as well. Our AZM40 is a compact flat design. It's a bistable operation, meaning that it remembers its last lock status in the event of a loss of power, 180-degree flexibility of the actuator with an inside emergency egress lever or push button option. The AZM201 series, again, another electronic-based, RFID-based unit that allows the ability to have individually coded actuators to enhance your tamper resistance, but it includes a door handle actuator assembly with a one-hand emergency egress. Hit the red handle from the inside, let yourself out very easily if you were to become trapped inside of a whole body access guard. The AZM150 is a traditional electromechanical type switch with a slim housing, again with inside emergency egress levers or push button options. Available with various contact arrangements. And then our AZM161, along with its associated STS30 door handle assembly with an inside emergency release on the switch and on the door handle, allowing you that emergency egress if you were trapped inside, again with various contact arrangements available.
Then they also talk about sensitive protective equipment, which can be light curtains or light grids. High level, they talk about these devices must meet IEC 61496, which again is a type B standard. So really at the end of the day, just know that if you have to use a light curtain or a laser scanner, it must meet the IEC standards. So just take a look at those mounted wire instructions and make sure that you see those IEC requirements called out. So we're not going to go into full detail of what those requirements are, but just know that ISO 10218 calls that out. And they gave an example of when you might want to use sensitive protective equipment. So before we looked at guards opening and closing, maybe you have a high frequent application and constantly opening and closing the guard door to interact with the robot. Maybe not the best solution, maybe even an ergonomic hazard. So we can look at something like a light curtain. Once we interrupt the light curtain or the laser scanner, we'll go into a safe stop.
So again, Schmersal has a solution with our unibody four-sided construction light grids, typically used for presence detection and perimeter guarding. And so that IP67 protection is standard with an IP69 protective housing available for applications requiring any kind of high temperature or high pressure washdown, typically in hygienic areas. LED status end caps, a 7-segment display. That unibody four-sided construction makes it more robust and but lighter weight because for 4 sides and then the lens. Integrated blanking, integrated contactor control, reset, double reset, beam coding, a high range up to 20 meters with a Bluetooth interface, and that Bluetooth allows that data transmission to either Android or Apple smartphones and tablets through our Schmersal SLC Assist app, giving you a diagnostic tool that allows for safe operation setup and documentation, giving you operating modes, OSSD status, the status of the protective field, the number of cycles, and so on. And the safety laser scanners, we partner now with a company called Hokio, and it's a very compact size, one of the smallest on the market, and a lightweight safety scanner that can be mounted in confined spaces, also for presence sensing, and giving you that 270-degree detection angle, a 5-meter protection zone, a 20-meter warning zone, or the option for dual zone monitoring option.
All right, now these slides, this section here is a lot of information, but what we are looking at is the information that we saw on the previous slide for resets for a sensitive protective equipment. So essentially, if we have, again, the idea of a full body access area, and we have light curtains that are monitoring this full body access area, for example, and we enter the hazardous zone, they enter this robot cell, we have to make sure that we can't restart this robot system with somebody inside. Okay, so yes, there's other safety functions that we can implement, such as a laser scanner to monitor the inside area, or safety mats, but depending on the area within this robot cell, that may be difficult to guard with mats, and maybe costly with scanners. So we have this idea, or the standard brings this idea of this double reset with using light curtains.
We have 2 series, the SLC 440 and the SLC 445, that offers that double reset to prevent that restarting of the equipment when full line of sight is not achievable and someone's within the danger zone, and very easily programmable to our 2 different light curtain series.
Perfect. The standard also goes into detail, and they refer heavily back to IEC 62046 for the different functions of a light curtain. So depending on application, you may have to implement blanking of the infrared beams, perhaps to allow material to leave an area, or to if there's ejection of a part from this area. Or muting, if we have to look at palletizers and muting pallets going in or out of a hazardous area. When you look at muting and with pallets, if there's a situation where there's a pallet that is stuck on a conveyor, section 588 calls out the requirement that there has to be a way to essentially override muting to allow this pallet to clear the muting sensors. So again, that's also called out in IEC 62046, but that's been now referenced in ISO 10218-2.
And our SLC 445 has integrated built-in muting, in addition to all the features of our standard light curtains with the blanking, which can be fixed or floating blanking. The muting, we offer various different options for different sizes of objects: partial muting, palletless muting, material loading with gaps, unforeseeable belt stoppages. So again, offering the integrated blanking or the integrated muting, along with complete muting sensor kits, in addition to some other features listed there, our PSDI and multi-scan with our SLC 445 series.
And then 5861 again calls out another standard. So this one calls out ISO 13856-1 and -2 and -3. But they're looking at safety edges, mats, and bumpers. So depending on the application, if you need to use a safety edge, mat, or bumper, this standard is just saying that you need to make sure that those devices conform to this ISO 13856 standard. Again, we're not going to go into detail of what that is. Just note that's what you're looking for, and make sure that you see that inside those mountain wire instructions, as you would see for the product solution we have here.
So our safety mats and edges, they do provide that tactile physical presence sensing. So our standard safety mats, we have 6 different standard sizes for industrial grade slip-free SMS4 style with a separate aluminum trim kit, and SMS5 offers that fail-safe, the integrated PUR rubber ramp rail trim built right into the safety mat system. And then our safety edges are used wherever you're going to have any moving edges to jeopardize the safety of persons or objects. So it's our fail-safe optical safety edge system, all 3 of which will be utilized with an appropriately safety controller to create that fail-safe tactile physical presence sensing.
Perfect. And as Dawn mentioned at the beginning of this section, we have products from Schmersal that can fulfill, as we saw, the requirements from ISO 10218. But also, again, we have Tec.nicum services. And again, with me being here in the services division, we want to highlight some of those services as well. So ISO 10218 calls out specifically the risk assessment. And even though the standard provides us guidance for safe design and safe integration, of course, it tells us that we have to do a risk assessment for our particular application. Tec.nicum services, we provide that service for a risk assessment. The standard 10218 calls out specifically, as an example for a risk assessment, ISO 12100, and we do use ISO 12100 as our base for doing a risk assessment. For collaborative applications, the standard says, yes, you still need to do a risk assessment. Again, that term collaborative robot no longer exists, right? So it kind of helps with this argument. So even if you have a collaborative application, you need to do a risk assessment. And again, Tec.nicum services does provide that as an offering. Okay. Also, when you look at some of the safety functions within ISO 10218, they call out having to make sure that certain guards or certain protective measures, like Dawn mentioned, for light curtains and safety mats, the standard talks about speed and separation monitoring, or SSM. Making sure that we are at a safe distance so the robot can work at its normal speed. The closer you get to the robot, it starts to slow down until you enter that hazardous area so the robot can go to a safe stop. In order to implement these devices or functions, you have to do a stop time analysis, and the standard calls that out. And they call out specifically ISO 13855. Again, Tec.nicum services offers the services to do a stop time analysis, and we also perform those calculations for the safe minimum distance for those functions and products. When we look at this idea of the class 1s and collaborative applications, as we mentioned before, the standard calls out certain pressures and forces that we cannot exceed to be able to use this as a true collaborative application with that robot in the same working envelope as the operator. So yes, we Tec.nicum offer that service to go on site to perform the pressure and force tests on those class 1 robots to make sure that they can be used side by side with the operator, and those tests would confirm, if there was contact, that those pressure and forces do not exceed what's called out within the standard. Okay, we are at the hour mark. Quick update on ANSI 15066. Obviously, this webinar was about ISO 10218. But just to give you a quick update on ANSI A3-15066, which of course is the American version, North American version of the robotic standard. So there's the purpose for the ANSI A3-15066 standard, which has been published as of earlier this month. Okay, so February of this year, ISO 10218 was published. Earlier this month, ANSI A3 was published, and it was completely harmonized to ISO 10218. All right, so everything that we spoke about for ISO 10218, you will see inside of the ANSI A3, completely harmonized. What we hope to see by the end of this year is an ANSI A3-1506 version, part 3, which looks at the requirements for the user. Right, so part 1 is the design, part 2 is the integration, part 3 will be for the user. And as you would expect, once that's published, we will have another webinar, if not at the end of this year, then next year, probably next year, to go over those changes, or in this case, what those new requirements are from this new part of the standard. Really quick, some resources that are available to you. Going back to the Technicum services, we offer training, full-blown training for machine safety, training on the standards, training on risk assessments, right? So everything that we spoke about today at a high level for this 1-hour webinar, we can go into full detail with the training. And our training is accredited by ISET, so we are able to offer continuous educational units. So we are really proud of our training program that we offer within Technicum. More resources that are available to you, and we have the link down there. I think some of these are in the handout, if I'm not mistaken, but we have some technical articles that are related around safeguarding robots and robot cells. We have some white papers that were published inside of EHS Today that you may have seen. If not, again, we have the links and we can provide those to you. We also provide MRO news through Schmersal, which is chock full of useful information for machine safety in general. And of course, we have that link in there specifically for robot safety. And I think lastly, some more information that we have here, some brochures that's specific for solutions. Of course, this case being robot solutions, and then I will link there for the products that Dawn mentioned, and so many more, so many more that we can offer. As he mentioned at the beginning, we're only going to focus on a handful for some of these requirements from the standard. Outside of Schmersal, these are the ANSI and the ISO websites that, of course, would have the standards themselves, but some additional information, especially with that A3, the ANSI A3 website. There's a lot of information on there. The first slide that I presented with those robot trends, that was from the website. That's their main focus, right? Robots. So there's a lot of information on there if you're not familiar with that. We are over the time, and I do apologize. I mean, we can do it. So some questions came in. We'll definitely get back to you, though. Answer those questions via email. Apologize, but hopefully the information was useful and helpful to you. And thank you for the questions, and thank you for your time, of course. Dawn, I'll let you close it out, Dawn.
Yes, thank you again for your participation. And again, a recording has been made, and that will be emailed out to you. And we will get to all those questions that came in. We apologize for going over. And thank you, and have a safe day.
Perfect. Thank you, everybody.